Hello everyone. Today we will start the medicinal chemistry first with the lecture 9, that is parasympathomimetic agent. In the lecture 8 we already covered the basic regarding parasympathomimetic agent and parasympathomimetic nervous system. So moving towards parasympathomimetic agent. First of all we should know the introduction part. Parasympathomimetic agents, as I told earlier, these are the compounds which mimic the action of acetylcholine and causes nerve stimulation. So these agents mimic means copy the action of acetylcholine. They play the same role as that of the acetylcholine and causes the nerve stimulation. Second point regarding this, the acetylcholine is the major neurotransmitter. Acetylcholine is the major neurotransmitter. These are further divided into the two types, direct acting and indirect acting. In case of the direct acting parasympathomimetic agents, here the drug binds to the nicotinic or muscarinic receptors and causes the excitation of cholinergic system. Means in the direct acting parasympathomimetic category, the drugs binds with the nicotinic receptors or the muscarinic receptors and causes their excitation also. In case of indirect acting parasympathomimetic category, here the drug inhibits the hydrolysis of acetylcholine, and that's why the concentration of the acetylcholine where increases. In direct acting parasympathomimetic category, it covers that the inhibits hydrolysis of acetylcholine and increases the life and concentration of the acetylcholine. So that's why the concentration of the acetylcholine at the receptor site increases and it leads to the excitation of cholinergic system. Excitation of cholinergic system, that is parasympathetic nervous system. So these are also called as anticholinesterase. So these agents are also called as anticholinesterase. So this is in brief introduction regarding parasympathomimetic agents. Moving towards its classification, as I shown here, the parasympathomimetic agents, are also called as cholinergic drugs, are divided into the basic three categories. First, direct acting cholinesterase inhibitors and cholinesterase reactivator. In case of direct acting category, there are the total 9 drugs are given. As I told, acetylcholine is the main one. In case of cholinesterase inhibitors, here the reversible direct acting category and irreversible indirect acting category. Both consist of few examples of the drug. In case of reversible direct acting category, the physostigmine, neostigmine are the very important. Irreversible indirect acting consists of parathion, melathion, which are the important. And the last, that is a cholinesterase reactivator, that is the third class from parasympathomimetic agent, which consists of only one example, that is paralidoxime chloride. Paralidoxime chloride. So we will see one by one in detail. Before going to see the drugs from this category, we will see exactly the SAR, that is structural activity relationship from this category. So see the structural activity relationship from this category, that is the SAR of parasympathomimetic agent, which is also called as cholinergic agents. So in that, as I told, the first class is direct acting drugs. So from the direct acting drugs, we will study one of the important drug, that is the acetylcholine. One of the important one is the acetylcholine. So considering the acetylcholine as a basic drug, we will study the SAR of parasympathomimetic agents. That is the SAR of direct acting agents. As I shown the basic structure here, acetylcholine consists of acetyl group, alkyl chain and quaternary ammonium group. This is the overall structure of acetylcholine, consisting of acetyl group, alkyl chain and quaternary ammonium group. Now we will see in detail its SAR. So first, in case of acetyl group, why it is necessary in case of acetylcholine? So see its importance. First is the ester group is important for hydrogen bond formation. First thing is that this ester group, that is a C double bond O and O, this group is important for hydrogen bond formation. Second importance is that this ester group, if replaced by the ketone groups, it will provide the more potent and stable compound. If it is replaced by the ketone group, so we will get the more potent and stable compound. Third parameter related with the acetyl group is that if the aromatic groups are placed towards the ester group, so acetylcholine antagonistic effects were increased. Third point, if the aromatic groups are inserted towards the ester groups, so it leads to the maximum antagonistic effects of the acetylcholine. Now moving towards the second functional group, that is alkyl chain. So what is the necessity of the alkyl chain in case of acetylcholine? First is that this acetyl chain or ethylene chain, it maintains the distance between the two groups. That is the first acetyl group and the quaternary ammonium group. In between these two groups, this ethylene chain or alkyl chain maintains the distance. Second importance is that increase in the chain length decreases the activity. If this CH2, here these are only the 2 in number. If this chain is increased, so activity of the acetylcholine going to be decreases. Third is that the branching of this acetyl chain leads to the change in activity. If we put the branching at this position, ultimately it leads to the change in the activity of acetylcholine. Now moving toward the third category, that is quaternary ammonium group. So regarding the quaternary ammonium group, only this quaternary ammonium group required, as it helps in the binding with the cholinergic receptors. So this quaternary ammonium group is required because it having the important role towards the binding of cholinergic receptors, that is muscarinic receptors and nicotinic receptors. That's why it is required. After that, the next point is that the replacement of this group, that is quaternary ammonium group, it leads to the loss of activity. If this group is completely replaced from the structure, it leads to the loss of its activity. After that, the third point is that, as I shown here, if this quaternary ammonium group is replaced by with 1 ethyl and 2 methyl group, 1 ethyl and 2 methyl group, so it leads to the more activity. It leads to the more activity or the increased activity of acetylcholine. But simultaneously, if the replacement will be done by with more than 1 methyl group, here as I shown, only 1 methyl group is replaced. But if the replacement will be more than 1 methyl group, that leads to the ultimately loss of the activity of parasympathomimetic drugs or decrease in the activity of parasympathomimetic category. So this is the SAR, that is structural activity relationship of the sympathomimetic drugs in that the direct acting category. Moving towards some important drugs from this category, which we will discuss here one by one. So the first is acetylcholine. As earlier we seen the structure, it is same. How it will act, mechanism of action show it. So this acetylcholine, it is a direct acting quaternary ammonium cholinergic drug, because here as I shown, it is a cholinergic quaternary ammonium drug and it has the muscarinic effects, means it binds with the muscarinic receptors, so it will show the muscarinic effects. Uses, it is used as a miotic in case of the intraocular pressure associated with the cataract surgery. It is used as a tonic action on the smooth muscles and the vasodilators also, means the effects of muscarinic receptors, the role of muscarinic receptors. Second, that is a carbachol, which is also the direct acting parasympathomimetic drug. Synthesis is as I shown here, the choline chloride treated with the phosgene, we will get an intermediate, and that intermediate is treated with the ammonium hydroxide, we will get the carbachol. Once again, choline chloride treated with the phosgene, an intermediate product is formed. The intermediate product treated with the ammonium hydroxide, so there will be the formation of carbachol. Moving towards its mechanism of action, it is also the quaternary ammonium parasympathomimetic agent, but it having the both muscarinic and nicotinic actions, means this carbachol drug binds with the both muscarinic and nicotinic receptors and show the action of the both receptors. Uses, it is used in the management of glaucoma, which is an eye disorder, and also used to produce miosis in the ocular surgery. Next one, that is the bithanicol. So as I shown structure, its mechanism of action, it is also one a direct acting parasympathomimetic drug, and it shows the muscarinic activity and little nicotinic activity, means the bithanicol binds muscarinic receptors and show the activity, and little bit binds with the nicotinic receptors and show the little nicotinic activity. Uses, it is used to stimulate the GI tract and it has the prolonged effect than the acetylcholine. So in order to have the prolonged use, one should prefer the bithanicol instead of acetylcholine. Next drug, methacholine. So methacholine, see here, as I shown the structure of acetylcholine, methacholine, carbachol and bithanicol. So compare all the structure, you will get the difference in each and every structure. We will study now the methanicol. Its mechanism of action, it is also a quaternary ammonium parasympathomimetic drug with the muscarinic action. So this drug also bind with the muscarinic receptors, so only it will show the muscarinic actions. It get hydrolyzed by the acetylcholinesterase. So this drug get hydrolyzed in the liver by acetylcholinesterase enzyme, and that's why it having the prolonged action inside our body. Its uses, it is used in the treatment of Reynolds syndrome and glaucoma. In earlier video, I already told what is the Reynolds syndrome, and glaucoma, that is the eye disorder. It is also used for the peripheral vascular diseases. See the peripheral vascular diseases as I shown here. Smaller arteries that supply blood to the skin becomes narrow, and that's why there will be the limiting blood flow to the affected areas, that we called it vasospasm as I shown here. So this artery that supply the limited blood in case of the Raynaud's disease, the smaller arteries are there and that becomes narrow and having the limited blood supply, that is a Raynaud's disease. So this is regarding the methacholine. Next, pilocarpine. In case of the pilocarpine, so this is an direct acting tertiary amine. So up till now we seen the 4 drugs which are the direct acting but the quaternary ammonium drug. But this is different, that this is a tertiary amine drug and it has the muscarinic effects, means it binds only to the muscarinic receptors and show its effect. Uses: it is also used in case of the glaucoma, that is eye disorder, in the treatment of eye or dry mouth, in the treatment of open angle glaucoma. It is also used as a diaphoretic in the diagnostic test for the cystic fibrosis and leprosy. So as I showed, a mild electrical current pushes medicine into the skin by the sweating, that is the diaphoretic as I shown here in this image, and this sweat is collected and given for the testing, that is diaphoretic diagnostic test in case of cystic fibrosis and leprosy. That is regarding the pilocarpine. So with this we will stop here. Thank you everyone for watching the video. We will continue with the next topic in next lecture.